This next video we're going to look at relative compression again, only actually this is more of an actual compression, but we're going to be using the pressure transducer with the picoscope. And so this is another way of doing a compression test if you have this equipment available to you. So let's go ahead and get started. First of all, let's look at the equipment, picoscope here, and I'm going to be hooking up to channel number 1. And you have to find in the box, you have to find the cable that actually has both ends look the same. So these ends look just like that. So that's what you need to find. We're going to plug one of these ends into the channel number 1. And so that's all ready to go. And this other end is going to go into the pressure transducer. Pressure transducer is this little guy right here. So just to give you a quick rundown on the pressure transducer, you've got the inlet port right here, and you can tell it's the inlet because it's right next to this brass piece. You got your outlet port right here, which is an electrical connection. So this part right here is not an electrical connection, because with a pressure transducer you can measure all kinds of pressure. You can measure fuel pressure, you can measure air pressure, which is what we're going to do with the compression test. You can measure oil pressure with it too. So, and then these other knobs, this right here on the side is a pressure relief valve. So if you're measuring like fuel or oil or something like that, you'll get fuel built up inside here and you'll need to let it out. This right here is where it will drain out of. And there's attachments you can put on here, so you can put a tube on it and run it out so you're not spilling gas everywhere or oil or whatever you're measuring. But this right here, you just crack it open to relieve the pressure so that you can undo your input right here. So that's what this is. Then the buttons on here, you've got a power button, and this has got an internal battery on here, so you do have to recharge it every once in a while. And when you power it on, the lights come on, and then you can zoom in, zoom out on it. This gives you a little bit of a range if you've got the adapters for like Bluetooth kind of thing. So that's what this is all about. So it looks like my battery is a little bit low. I'm going to have to charge it, but I think it's strong enough that we can do this test. So what we're going to do is we're going to hook up the other end of that cable to this, and this is ready to go. So the other piece that you're going to need is you're going to need the adapter that goes in the cylinder. So this adapter right here has got a bayonet connecting on, or I mean not a bayonet, but it's got a collar that you pull back, and it clips on to your pressure transducer just like this, just like you would plug in an air tool. So that's the way that clips on. The other end of it, I've got an adapter that is going to screw into the cylinder. And so I'll grab that adapter and then I'll show that to you. Here's the adapter that goes on the end of this thing. It just screws on. And it's the adapter that would be the same as the spark plug threads. And here's an opportunity for you to learn from my mistake. When you screw this thing on there, take a wrench and just snug it down. You don't have to crank it down really tight, but just snug it down enough so that when you take this thing out, the adapter doesn't come off the end of your sampling tube. Got the pressure transducer all hooked up, so it's down into the cylinder and it's turned on, ready to go. It's hooked up to the picoscope. So let's go ahead and fire it up and see what. Now we're going to do a cranking compression test on this, and so you can do a running compression test as well, but we're going to do the cranking compression test and go from there. So let me set the camera up, and we're going to go ahead and start our trace, and we're going to crank it around, and we'll see if we can stop it and look at what we got. Okay, I've paused the trace, and what this is this is telling us what our relative what our compression is using a pressure transducer. So if you see, the spike goes all the way up here to a little over 100 and looks like it's probably about 160 pounds, and they're all even. So every time this thing cranks over, that cylinder looks pretty good. So this right here, you see that little dip? That's kind of interesting. That's where you got a little bit of valve overlap going on. But anyway, so that's a compression test using a pressure transducer. Now we're going to do a running compression test, and this is kind of an interesting test with a scope, because as you'll see when we get the test going, you can look at all the 4 strokes of the cylinder right here on the scope. So you can look at intake, compression, power, and exhaust. So the setup is exactly the same. I've still got the pressure transducer hooked up into the cylinder, and everything is set up the same. The only difference is you come up here to the automotive drop down, we go down here to pressure, we go to pressure transducer, we go in cylinder, and we select running compression test instead of cranking compression test. So that's the only difference. So we're going to select that. It'll start up and it'll give you an example waveform. Now the example waveform that we're looking at here, if you look right here at this peak, this is where your power is. So the piston's going to come down on the power stroke, and it's going to bottom out, and then the the exhaust valve is going to open up, and this will be the exhaust stroke. Then the intake starts, and so when the intake starts, you have a pressure less than atmospheric. So if you see, this is 0 right here, this is your exhaust. When you come down here, you're going down lower than 0 psi. So this is the intake, and then the intake valve closes and we start to compress, and so we compress up here. So we have intake, compression, power, exhaust. So again, that'll be intake, which is down below below 0 psi. So intake, compression, power, exhaust. And so it's really cool. So let's take a look at the engine while it's running. And so I'm going to start the trace, and we'll start up the engine. Oh, got to turn on my transducer. I turned it off a minute ago. Okay, my pressure transducer is turned on. It's ready to go. So let's go ahead and crank the engine over and get it started. Okay, I paused the trace so that we can take a look at it, and this looks very similar to the sample trace that Pico gave us. And so we have our intake, compression, power, exhaust. And along the way, you can see a couple of little ripples here. You'll have a little bit of valve overlap between your exhaust and your intake, and your fuel injector is going to fire somewhere along in here on the power stroke. So when you have compression and then power, so actually it'll probably be firing like right about there, right before the peak of the compression, because usually we want to fire the cylinder about 10 degrees before top dead center at idle. So if we're going faster than idle, we're going to fire it sooner than that. But anyway, if you want to get into it a little more advanced, we can do that. We can actually add the fuel injector trace on here. We can probably do that later on in the quarter. So we can add the fuel injector trace, we can add the spark ignition trace on here, and then we've got the compression test right here. So that way you'll be able to see when the spark fires, when the fuel injector fires, and what's going on with the compression. So really cool test that you can do with a scope. So I don't think there's a specific task for this, but I would highly encourage you to use some lab time and maybe play around with this a little bit. So anyway, that'll conclude this video here.